Hello and welcome to Statistically Significant. In today's video, I will discuss how to perform a two-way ANOVA using the Rstudio software. So today we are given a data set on the ratings of 10 different service stations given by 5 professional raters. We have two hypotheses to test here. The first null hypothesis is that there is no significant effect of the professional raters on the ratings against the alternative that yes, there is a significant effect of the raters on the ratings. Our second hypothesis to be tested, the null hypothesis, is that there is no significant effect of the service stations on the ratings against the alternative that yes, there is a significant effect of the service stations on the ratings. Now let us have a look at the data in hand. The original data was given in this format where capital A, B, C, D and E are the 5 different professional raters and small a, b, c, d, e, f, g, h, I, j, they are the 10 service stations. And the numerical values, these are the ratings given by the professional raters to the service stations, and we are to test whether there is an effect of the professional raters on the ratings or there is an effect of the service stations on the ratings. So our response here is the ratings which is being affected by two factors. Factor 1 are the professional raters and factor 2 are the service stations. Now, as our response is being affected by two factors, we are assuming the two-way ANOVA model here. And the two-way ANOVA with one observations per cell, and that's why no interaction is assumed in this model. To assume interaction, we must have replications of our response variable corresponding to the two factors. As we don't have any replications, we cannot include interaction, or we cannot assume interaction in our ANOVA model. So now the original data was given in this format, but for R to read it, but for making R easily read this data, we have to enter the data in such a manner such that it becomes easy for R to differentiate the different factors and the variables. For this, I have entered the data like this. You can see this CSV file where these are the professional raters denoted by the capital A, B, C, D and E, and the small a up to small j, these are the service stations and these are the ratings. Okay, so now I'm going to read this CSV file into R and perform a two-way ANOVA test. For this, I use a library function readR. Now using the read underscore CSV, enter the file name, and now R has read it. Just have a look at how it looks. This is the actual CSV file which R is reading. Now you could see that R is treating the ratings as numeric variables, and we wanted R to treat the ratings as a numeric variable, but the service stations, R is treating them as a character, and similarly the professional raters, they are also being treated by Rstudio as a character, but they are not character, they are actually the factors affecting our ratings. So we need to convert them into factors, and for this I use the as.factor function to convert these professional raters and the service stations from character to factor. Now same for the service stations. Now just have a look. Now R is treating the service stations as a factor with 10 levels. That's what we wanted. And R is also reading the professional raters as a factor with 5 levels. So we have successfully converted the characters into factors. Now we move on to the analysis of variance. So let me name something. Let me give me a name. Serve rate. You can use any name. Use the AOV function and enter the formula. Now as you are using the AOV function, you must specify the data at the end. Now I will use the summary function. So this is the ANOVA table which we wanted. Have a look at it. We had 5 professional raters and the degrees of freedom becomes 5 minus 1, 4. We had 10 different service stations. The degrees of freedom becomes 10 minus 1, 9. Totally we had 50 observations and the total DF comes down to 50 minus 1, 49. Now when you subtract 9 plus 4, 13 from 49, you get the error DF, which is the residuals here, the error DF which is equal to 36. Now the important thing which we need here is the p-value. This is the f-value column. We have got f-values corresponding to the professional raters and the service stations. But the most important part is the p-value for concluding or giving a conclusion of the test. The p-value corresponding to the factor professional raters is more than the alpha value, which is taken as default 0.05. So it is more than 0.05. So we conclude that we fail to reject our null hypothesis in this case and conclude that there is no significant effect of the professional raters on the ratings. And in case of the second factor, the service stations, we see that the p-value is much less than alpha value 0.05. So in this case we have to reject our null. We fail to accept our null and conclude that yes, there is a significant effect of the service stations on the ratings. Now you can perform a post-hoc test using the TukeyHSD function, Tukey honest significant difference test, and that's it. R performs the TukeyHSD test, which is a pairwise comparison test corresponding to the two factors. Now see, Tukey test corresponding to the factor professional raters. R is pairwise comparing the professional raters, capital A up to capital E, pairwise, and you can see that for each of the pairs the p-value is way larger than the alpha value 0.05. so we fail to reject our null in case of the professional raters. Now for the service stations, it also does a similar pairwise comparison test, and from this we can conclude which of the pairs differ, have a significant difference among them. So just have a look. Pair B and A, that is service station B and service station A, corresponding to them the p-value is much less than 0.05. so they have a significant difference between them. Similarly, between service station C and service station A, the p-value is again much less than 0.05. so yes, there is a significant difference between service stations C and service station A. Again, substation D and substation A, you could see that the p-value is way larger than 0.05. It's almost near to 1. So there is no significant difference between substation D and E. So you could conclude from these p-values that which of the pair of the substations differ among themselves and which of the substations do not significantly differ among themselves. So this is how you perform a two-way analysis of variance in Rstudio. Now I would like to add one thing. You could use the same code to perform a randomized block design experiment test in Rstudio. But keep in mind that two-way ANOVA and randomized block design, these are not the same thing. The mathematical procedure is same, but in randomized block design or RBD, we first stratify the different experimental units into homogeneous blocks and then apply the treatments on them. Whereas in two-way ANOVA, we simultaneously apply two different factors on our responses. So experiment-wise, these are two different experiments, although they have the same mathematical procedure. I hope you guys have I hope you guys have understood how to perform a two-way ANOVA in Rstudio. So do like, share and subscribe. Thank you for watching.